Hey guys, welcome back. This is the F1 score with this cancer multi-class classification model we're going to be building. Here's the thing, guys. This is a very imbalanced data set, so this is somewhat acceptable. However, if you guys want to improve this model, I'm going to leave a link to how to hypertune the parameters of a naive Bayes classifier, which is the same algorithm we're using in this project. So if you guys want it, just click on the video if you guys want to improve it. Also, I'm going to leave a link to a multi-class Streamlit web app. Since this is multi-class, you guys can apply the code from this project accordingly, which I'm going to explain how to tweak it, and then you guys can make your own web app. I recommend both the videos for a very accurate model, though. Anyways, guys, without further ado, let's get started. We're also going to do some inverse transform. You guys see YPRED, the prediction? I got it decoded. You guys see? So this is the decoded prediction. You guys see? Okay. Anyways, guys, if you guys are new to my channel, before we get started, I shouldn't have said further ado. Please check out some of my other videos. If there's something you're here for right now, there's something else you need. I've got reinforcement learning videos. I've got SageMaker pipelines with MLOps. I've got SageMaker models just itself. I've got Google Cloud and Azure deployments. I've got Streamlit AI ML web app deployments on Render Cloud and Streamlit Cloud. Anyways, guys, and I've got NLP web apps, with Streamlit on Render Cloud and Streamlit Cloud. Language detection and sentiment analysis. Anyways, guys, I've even got image classification and tons of convolutional neural network videos. I've got pretty much everything. Reinforcement learning for trading. You guys name it, I got it. I've done all the OpenAI Gym games and the ML framework, ML agents framework video. I've done reinforcement learning for trading. You guys name it, I got it on this channel. I've even got data science tutorials like this. Eventually, guys, when I'm done with the little data science side, I'm going to get back to the technical side again. Do something I haven't already done on this for videos. Anyways, guys, I'd really appreciate it if you guys shared my videos. Every bit helps. And anyways, guys, now it's time to get started. Import NumPy as MP. Import pandas as PD. Read the file. Oh, and I almost forgot. This is the video. If you guys, I did a video how to cluster these as well. I'm going to leave a link to that as well. How to cluster this data set, for patient segmentation. Check out that link down on this video as well, if you guys want to cluster. And I'm going to leave a link, of course, to the data set on Github. Anyways, guys, read the data set. DF head. As you can see, we're going to need to drop some columns. And this is our target, the cancer detailed type, not just simply cancer type. This is a very imbalanced data set. See some of my other videos where we explore more in depth the data set to tell you how it's imbalanced. DF info. Okay. Now, as you can see, we're going to get down to... We're going to drop all of these columns on an axis of 1. DF drop all of this. All the irrelevant columns. Now, and then we're going to name it DF1. DF1 info. And DF1 head. And now we're going to label encode it. And guys, as you guys saw at the end with the LE transform function, you can decode predictions, columns you encoded, it doesn't matter. But before we get started, I wanted to tell you guys that, like we saw down there. As type string, LE transform fit, df1 fill in A for all the nons. Put it in with a neutral number, a 0. And guys, that's for the minimax scalar, which we're going to do. Here is your target. Here is your target. And then drop everything but. Drop. And basically your target is here. I misspoke. And then x equals drop this, so everything but that. Camera. Okay, both on an axis 1 and the values. So you guys see, there's your target, everything but that. Okay, import test train split, size 20%. Make the pipeline. Yes, we're going to use a pipeline because there's an issue with the minimax scalar without a pipeline, so we're going to be using a pipeline. Polynomial in B. X train, Y train, fit. There's a little pipeline. You guys see? It's different than an MLOps pipeline. You guys know? An MLOps pipeline is what you use to get models approved for production and perform MLOps. Retraining the model on data, version testing. You see some of my other videos with SageMaker pipelines. I'll explain more. This is a different kind of pipeline. This is a very simple pipeline. SageMaker pipelines, get ready to code. Okay, guys. Model predict X test, confusion matrix, YPred, Y true, Y test, confmat. Okay, and then we're going to make it the fig size. Name this, remember the X is predicted and true, although you guys can name it, predicted, whatever, true, whatever. You guys can change that if you want. The confmat shape, because remember the confmat is what we use. Remember, guys, in the real world, if you're working in business, your clients understand confusion matrices. Even non-technical people you'll be working with, you'll have to explain to them confusion matrices to show them how your model's working. Be advised of that if you're a student. Whether you're a freelancer or working for another company, it doesn't matter. All non-technical people understand that. That's why with data visualization, we help spell it out, the true and the predicted. There's your F1 score. As you guys can see, you guys might want to hypertune the parameters to improve the model. See my video for that link. And remember, the average is macro because it's multi-class with the F1 score. F1 score, you're trying to get at least 70%. 70% is like the bare minimum. However, this is an imbalanced data set, so we did the best we could. Okay, now an ideal for an imbalanced data set is probably about 85% because it's imbalanced. Now the mean and the median function. Okay, and then remember the LE transform. See my video for Latin natural language processing where we do language detection. We use the LE transform function to decode predictions. So it's spelt out. This language is English, this language is whatever. It doesn't matter. And there's our prediction. I LE transformed it. YPred. You can LE transform columns you encoded before, like I told you. Now, guys, remember, like I told you, the video I'm going to leave a link to, guys, prepare to code and prepare to put a lot of columns because you got 50, hold on, let me look at the new, okay, I see, so you have 53. Anyways, guys, prepare to code 53 columns. Like I told you, you guys are going to have multi-class, so I'm going to leave a link to a multi-class web app so you guys can tweak the code from that video accordingly from this project. And I'm going to explain how to add more classes for the prediction also in that video. You guys see? So you guys can tweak it accordingly. And if you guys do the hypertuning the parameter video, you guys can improve it as well. And then you guys did something I haven't done. You guys see? Well, for this project specifically. So this is why I encourage you to build on both of those videos, if not all three, and go off and do it on your own. You know? Each one of my videos, I recommend you guys build on it. You know? Make it your own, improve it, including my reinforcement learning videos. Check those out. Build on it, you know? Improve it. Make it have less time steps, less penalties. Anyways, guys, I hope you learned from my video. Stay tuned, and if you're new to my channel, hit like if you liked it, hit subscribe if you haven't. For those who've been watching this whole time, I really appreciate y'all. I'm glad you've been watching this whole time. I really mean it. And guys, just so you guys know, the videos will continue. They may slow down sometimes, but I'll always be on. Don't worry about that. Anyways, guys, I hope you like my video. Stay tuned. Thank you. Bye.